Hi there, I'm Professor E.
And I'm DJ Schurz.
Welcome to the Robot Program. Now, DJ, I see you have some glyphs with you today. What are we going to be doing with those?
These are glyphs, and we are going to be using these so that the robot can move forward when I pull the glyphs away, and when I push the glyphs closer to the robot, it'll move back.
Okay, so it's going to try to keep a distance between itself and the glyph at all times.
Yes.
Okay.
Now, this is an application you will see if you watch videos about the Boston Dynamic robots, for example. You'll see glyphs posted around various areas in the room or on boxes. Glyphs are used for robots to be able to identify how to pick up a box or how far away the box is based upon the size of the glyph in the camera image. So we're going to be using the size of the glyph to identify how close it is to the robot's camera.
And if you want to learn more about glyphs, you can check out one of our other episodes.
So in this episode, we are going to be using 6. Now, we can use any of these robots.
Any one of these 4.
And at the end, we'll show you this application with all of these robots. So let's grab 6, and we'll turn them on. Set them down. And we will load Easy Builder. Locate it in your Start menu. We'll skip going to Easy Robot School and connect to the Wi-Fi network of your robot. Now, we're going to click on Example Projects, and the example project we're going to load is going to be the bear project for your robot. So in this case, we're going to load 6 bear, but if you have AdventureBot, JD, or Roll-E, choose the bear project for those robots. So I'll choose 6 here.
And we want the bear project because it's a nice clean workspace that we can start from, add whatever controls we need for our activity.
Boom!
Ready to go.
And 6 comes to life. Okay, so we're going to need to add the camera control because we want the robot to be able to see things. So to do that, we'll click on Project, Add, Camera, and choose Camera Device. And we'll push the Start button. And there's Andreas taking notes. Say hello, Andreas. So we'll turn 6 around so he can see me, and I'll put him right about here. Now, we know that when we hold the glyph up, on the screen, there's a specific size for it. We want to turn that size into pixels. So here's how we're going to do it. We're going to choose Tracking and turn on Glyph. So now when I hold the glyph up, you can see there's a blue box around it. When I rotate the box, you see it gets bigger. So you're going to want to hold the glyph straight. Otherwise, if you rotate it, you're going to get that same effect where the robot's going to think it's closer or farther away from the object. Now what I'm going to do to be able to see the size of the box is I'm going to click Add in Project again, and I'm going to choose under Scripting the Variable Watcher. Now this is going to show me all of the variables on the system and what their values are. And the value that we care about is the object width. So that's the width that the object is currently detecting. So if I hold it right about here, you'll see it's about 100, 120, 114. And if I come closer, 130, 140. When I come back out, 190. You see that? But if I rotate it, you see it gets really big. So it thinks it's closer. So whenever we do this application, this practice, you're going to want to make sure the square is the same. So I think the numbers that I'm going to go is anything greater than 110. Okay?
Okay.
The robot is going to move back. And anything less than 90, the robot's going to come forward.
So you're giving it about a 20 range there.
Yes.
So it's going to try to go forward or back, depending on how far or close the glyph is.
So if it's in between that range, it's just going to stop. It's not going to do anything at all.
Now here you're tracking, so you've got the variable and you're looking at object width. We're using a glyph. What else could we use?
You can use any of the object types, and you can check all of the other different tutorials to see how to use those object types, such as multicolor, objects, even your face. So we're going to choose under File, the Blockly workspace, and then we're going to start our Blockly program. So the first thing we want to do under Camera is we're going to set camera tracking. I'm going to set the camera tracking to Glyph, because that's what we're currently using. And then we want this to loop. So we're going to tell this to loop forever. And we are also going to add in, because we're going to be looping forever, a sleep at the end of our loop. So every time it loops, it's going to pause for about 1 second, and that's going to give the computer a time to be doing other things because it's a multitasking environment. We're going to add an if condition into here, and this if is going to have an else. And we want to check to see if the camera is currently detecting or currently tracking an object. We can do that by clicking on the camera, and if we scroll down, you'll see that there's a bunch of different variable comparisons. This is the camera tracking equals true? Yes, so we want that and put it there. Now if the camera is not tracking, we want the robot to stop. just in case it's last time it saw the glyph, it was moving a certain direction. If you take the glyph away, we want the robot to be able to stop.
Yeah, we don't want it to keep walking off the table.
And not run away. So now let's add some other if condition in here. In this one, we're going to need an else if and an else. And here's why. Because we're going to add in this comparison and our variable. The variable I mentioned earlier we're going to look at is the camera object width. And we want to put some math in here. So we want the camera object width if it's less than, so we'll use this one here. This means equal or less than. Okay? We'll add this in here, and we're going to say if it's less than 90, then what do we want the robot to do when it's less than 90? That means it's far away.
We want it to come a little bit closer.
Forward, okay. So we're going to go into movement here. We're going to add in the forward. And now we want to duplicate this piece of code because we can copy it and put it in the else. We want to change this now to the other way. We want to say if it's greater than, and the number we chose was 110. We type that in. Now we want the robot to do the opposite, which is go in reverse. So we'll choose reverse. And then finally, in the else condition, if it's not greater than 110 and it's not less than 90, means it's in that middle range, we want the robot to stop. So we're going to take the stop command here. We'll just duplicate it and drag it up there. Now the speed we want the robot to work at is going to vary depending on the robot that you're working with, also the size of your table. So I'm going to make this robot move full speed, so I'm going to specify its speed to be 255. So the speed is a value between 0 and 255. 0 would mean not moving at all. 255 is always a full speed.
Top speed.
Top speed. And of course, 127 would be your middle speed. So here's our program. And it looks like it should work. We'll push the start button and give it a test.
Let's see it.
Okay, so let's move these guys out of the way so we have some space for 6. We just knock him off the table. We'll push the start button. And there it goes. And you can see it's looping every 1 second.
Right, so you can watch and see how your program's executing in the console.
So we'll hold up the glyph. Now I'm going to stand back farther. And he's going to come to me.
So when he stops, he's in that sweet spot.
He's in the sweet spot. So when I come closer to him, he's going to back up. I'll come forward again.
So now we're going to execute the same code, but with AdventureBot.
So there's 3 changes that need to be made to AdventureBot for our program.
Okay.
The first is inside of the servo movement panel. You're going to click on the gear, and you want to check the use checkbox, and then push the test button on each of the stop values, and your robot shouldn't move. Okay, and that's good when it doesn't move. If it does move, check the calibration tutorial and calibrate the servos. So we'll push save, and we'll revisit our Blockly program. Now this is a Blockly program we had made earlier. The second change we have to make to this program is the speed in which the wheels are going to turn. If the speed is full speed at 255 for AdventureBot, he's going to whiz right off the table.
Just go right off. He's pretty fast.
So we tested already speeds for this robot, and we came up with 2 numbers, which was
20 and 30.
20 for the left wheel and 30 for the right wheel.
To move forward.
Moving forward. And you're going to want to reverse those numbers for backwards in reverse. Those numbers allow the robot to move forward on a straight line or reverse in a straight line. Based upon your calibration, you may have to experiment with different numbers to get it to work at the right speed.
Whatever works for your robot.
And the last change is going to be how often it checks to see if the robot is detecting the object. We're going to change that to 250 milliseconds because he's going to move a little quicker than 6. So we want to check it more often, so 4 times a second. Okay, so we can start it out. You ready?
Okay, we're ready to try this?
Here we go.
Forward. It's running away from you.
That's so much fun. And if I tilt it, he'll see it as being bigger.
That's right, and you can watch the blue box around the glyph.
Oh, that's so much fun. Okay, so let's do it with another robot. Shall we try it with Rolly?
Okay, let's do it.
So we got Rolly. So we have to make, again, 2 changes to Rolly like we did with AdventureBot. In this case, we're going to go back to Blockly. And the first change is to make the speed difference. So we're going to change the speed to be half the speed, which is a value of 127. And we'll do that for all of these speeds here.
So moving forward and back.
and we're going to check, instead of 1 second, like we did with first one, we're going to do the same thing we did with AdventureBot, change that to 250 milliseconds. Let's give it a shot.
Okay.
Push the start button, and here we go.
Hold up your glyph.
Okay, we got next is JD.
Last
So
but
let's
not
try
least, JD.
So for JD, we don't have to make any changes because 255 gets him walking at a decent speed, and the 1 second delay for the loop is perfect. So I'll push the start button, and let's give it a try.
Okay, we see our blue square. There he goes.
He's coming after me. Now I'll come forward towards him.
He backs away.
And I'll come back. And he's coming back at me again. So when I take it away, JD will stop.
Good, that's our last else statement. We said if you don't see it, stop.
You got it. So now you've seen this example with glyphs, having the robot follow forward and backwards on all of the Revolution robots.
In this episode, we showed you how to train your robot to maintain a set distance from a glyph. For example, if I hold up a glyph and bring it towards the robot, we want the robot to back away. If we move the glyph away, we want the robot to come closer. If the robot is within the sweet spot of the range, it'll just stay still and not do anything. This application is an example of how we can use glyphs to provide information to a robot, such as identity or interaction information. And you can learn more about glyphs in one of our other episodes. We used Revolution 6, but you can use any of the Revolution robots that has a camera. Power on the fully charged robot and load up the Easy Builder software. Connect to the EasyBee using the Wi-Fi connection, and then open the Bear project for your robot. The Bear project provides a nice clean workspace with only minimal controls. Press the blue button to connect. Because we need the robot to see something, we'll need to add the camera device control to the project. Click the green Start button to start the camera device. Click the Tracking tab of the camera device and select the Glyph checkbox to turn on Glyph tracking. If you hold a glyph up to the camera, you'll notice a blue box surrounds the glyph. If you rotate the glyph, you'll see that this box actually gets bigger. That's because it is surrounding the whole bounded area of the glyph. This box width can be represented using pixels, and that's the pixel size that we're going to use for the rest of our activity. Hold the glyph straight for the most accurate box width. Now that we know how to measure the width of the box, we need to decide what number of pixels are going to represent the close value and the far value of our range. From the project controls, go into the Scripting tab and add the variable Watcher. This control shows all of the different variables that are active in your project. Scroll down until you find the variable called Camera Object Width. This variable is going to update with the number of pixels of whatever the box is detecting, so it's going to use the width of that bounding box. Move the glyph back and forth to determine which numbers you want to represent your close and far values of your range. In our example, we chose the value 110 pixels if the robot is close to the glyph, and 90 pixels if the robot is further away. These bound the range of what the robot is going to use. Remember that the closer the robot is to the glyph, the larger the width will appear. You can also do this activity with other types of tracking, such as object or color. The variable camera object width is always the one that is used to determine the width of that bounding box. Now we need to write the code that will tell the robot what to do when it detects a glyph. From File, go into the Blockly workspace to write the script. From the Camera menu, choose Set Camera Tracking and set that value to glyph. This sets our type of tracking to glyph tracking. From the Loops menu, choose Loop Forever. This structure will loop the code that we write forever until we decide to stop our program. Because we need time for the robot to execute what we tell it to do, we're going to add the sleep function to create a pause. Add a sleep command for 1,000 milliseconds to the very bottom of the loop function. For some robots, such as Rolly or AdventureBot, you can change this sleep number to 250. Since those robots move more quickly, we need to actually check for the new command more often. First, we have to determine whether or not the camera is actually tracking a glyph at that moment. From logic, add an if-do statement, and then click the gear button to add one else statement. From camera, add the statement called camera is tracking. If the camera is currently tracking a glyph, the value of this will be set to true. If it's not, it will be set to false. And if it's false, and that means the camera's not tracking a glyph, we want the robot to just stop. This means you need to add a stop command to your else statement. Now we have to add nested if logic. This means that if our robot is detecting a glyph, we're going to have some other if statements that determine what it's going to do. From logic, add another if do statement and put it in the do statement that you already have. Click on the gear icon and add one else if statement and one else statement. This now gives us 3 different options if our robot is tracking a glyph. The first option, if the robot is further back than our maximum distance, we want the robot to move forward. If the robot is closer than our minimum distance, we want the robot to back up. And if the robot is in between our range, we want it just to stop. Now we need to code those 3 options. From logic, choose the equals comparison statement. Put the variable camera object width into this comparison statement and put in the first range to be tested, for example, 90 pixels. Change the equal sign to less than or equal to. The camera object width variable is going to be updated with the last detected width of the glyph. If the detected width is less than or equal to our 90 pixel range, we want the robot to move forward. Add a move forward command to the do statement. For the else if statement, if the detected width is greater than or equal to 110 pixels, we want the robot to move further away. Go ahead and add a reverse statement to the do statement. If the width of the glyph is within the range that we set, the robot shouldn't do anything. Add a stop command to the else statement. Change the speed settings as desired for your robot. 6 and JD will need a value between 0 to 25, stopped or top speed, and AdventureBot and Rolly will need some adjustments as well. Click the green start button to execute your code. In the console window, you should be able to see when the code is looping every 1 second or 250 milliseconds, whatever you set as your sleep value. Test that your script is working correctly by holding the glyph up to the robot. If you move the glyph towards your robot should reverse. If you move the glyph further away, your robot should come towards it. Glyphs are a great way to interact with your robot. Thanks for watching this episode, and we'll see you next time. Which variable stores the width of the detected glyph? True or false? The glyph width will increase as the robot moves forward. Why is camera object width compared to the range endpoints? Find the answers at therobotprogram.com.